All right, in this video, we're going to go over the first page of this extra practice for propositional logic proofs. So essentially, the first thing we're going to do is we're going to prove two rules that we would like to continue to use throughout the rest of this this practice. Technically, these things are just based off of the rules. You just might not recognize that they can be used in that way, so that's why we're going to talk about them first. So the first thing we're going to prove is that essentially if we have P, then we can conclude P and P. So if we do a very simple, very basic, I should say, proof table, so our statements and our reasons. So remember, the givens are everything to the left side of that double arrow. So the only given we have is P. And then we want something that will be able to allow us to conclude P and P. Now, if you think about it, if we go over and we look at our rules, which I have to the right here, and I look to see that something will produce an and, something that starts without an and produces an and is only conjunction, that first rule at the top of the inference table. So that would mean that we would have to have P and P. But technically, you can use that statement twice. So it's not that we have to have it again, we already have it, and we can just draw upon it twice. So technically, the only step here is to just conclude P and P by conjunction. And it would be conjunction on step 1, so I'll write that as well. So essentially, again, the reason for this is you know P, and so you can use it twice. With the conjunction rule. So you know P and you know P, so you can include P and P. Now for the second one, we want to take P and P and conclude P. So we essentially want to go the other way. So if we draw our basic proof table again. So again, the givens are the things that are on the left of the double arrow, so we only are given P and P. And we want to look at our rule and see something that takes an and statement and essentially removes the and. The only thing that removes the and is a simplification rule. And in this case, we just have P and P instead of P and Q. But that's fine because remember, it doesn't have to follow the exact format in terms of having the specific letter. It just has to be the pattern. So we can use simplification here to just conclude P. So that would be simplification on line 1. So now say we want to prove a couple other things as well that we're going to want to use. So the one thing I want to say before we move forward is essentially what's going to happen is, and it actually kind of concludes this down on the bottom, is since we're able to prove it in both directions, it's now actually going to be able to be used like an equivalence rule. So that's why we're building this up. So let's do a very similar thing with these two next ones. So we have P and we want to conclude P or P. So we write our basic proof table, statement, and reason. We are given P, and we want to somehow conclude P or P. So we look over at our rules, we try to look for something that only starts with a singular statement and ends with an or. The only one that does that is the addition from the inference table, the last rule in the inference table. So by addition, we can add on P. We can add on whatever we want. This could be P or R, P or Q, but the only thing we actually care about here is getting a P or a P, so we're just going to tack on another P by addition. So that would be addition on line 1. Now we essentially want to prove the opposite direction. This one is actually going to take a tiny bit more work than the rest of them. This one's going to have a couple more steps. So we have statements, and we have our reasons. And our hint here was that we wanted to use De Morgan's law and then what we actually proved in number 1. So we're actually going to need to pull what we proved from the first set of proofs to be able to finish this one. So the first thing is we want to write down what we're given, so that's just P or P. And now we're asked to use De Morgan's law. So De Morgan's law here, remember, that's essentially the one where you essentially negate the entire thing or pull out a negation, if you will. So here, since these are both just regular p's, we can also think about this as not p or not p, if you will. And this would be using double negation. Essentially twice, so I'm kind of cheating a little bit because it should technically be in 2 lines on number 1. And then using De Morgan's law, I can essentially pull one of those negations out. But remember, sorry, I wrote it wrong. So you'd have not p. And remember, when De Morgan's law, once you pull that negation out, it switches the sign. So that would be De Morgan's on line 2. And then notice that we have not p or not p. It's the same thing. Sorry, that's an and. Not p and not p. So we have the same thing combined together with an and we know from part 1 that if we have p and p, we can conclude p. So in this case, we can conclude not p. And that would be essentially by, I'm going to say at this point, proved p and p gives us p, and that would have been on line 3. And then the last step is we can use double negation again on line 4, and now we've concluded just regular old p. Now I will say, if you look at the answers on Blackboard, I added in the step of double negation. Technically, the answers I have on Blackboard are correct to use De Morgan's law. It's just not quite as specific, and we should probably be a little bit more specific, especially when we're starting out, to kind of show why we can use that De Morgan's law. There are nots in that statement. It's just that a normal p can also be thought of as not p, and then we have those knots that we can manipulate. So essentially, again, the point of doing all of that is to be able to essentially go both ways. So we've proven these two things in both directions. So that means that they're not just inference rules as they were stated, but they're actually equivalence rules because we can go in both directions. So we're going to want to be using these rules throughout the rest of the extra practice. These 2 extra rules will not be used on an official assignment. You know, if you ever actually needed to conclude it, you would just conclude it the normal way using addition or conjunction or anything like that. But you won't need to call upon these rules on, you know, a homework set or a quiz or a exam. These are specifically just to help us get through some of these extra practice that kind of need those, and we don't want to keep always going through that same process every single time we need it. We don't want to keep having to essentially recreate these proofs we just gave. So that's the end of the first page, so I will end this video here. There will be some other videos for the rest of the pages of this extra practice, so check those out if you need that practice.